Hello everyone, my name is Anvita Bansal and we are back with another lecture based on hash map. So let's see the problem for today. Before that, let me check if you guys are able to see my screen. Works. Okay, fine. So let's have a look for our problem, which is zero sum subarray. So let's have a look. So in this problem, you are given an array of size n. Find total count of I think we have discussed this problem. Just a second. Okay. So we are going to discuss longest consecutive subsequence. Let's have a look at this problem. We already discussed the other one. Okay. So you are given an array of positive integers. Find the length of longest subsequence such that elements in the subsequence are consecutive integers. The consecutive numbers can be in any order. So what do you understand by this problem statement? You are given an array. Fine. So you need to return the length of such subsequence in which what you get are the elements which are consecutive. They need not to be in the same consecutive order, but the elements that are present, those should be consecutive. Okay, now let's understand it. What are they trying to say? Let me take this example. Okay, so this is your test case. Okay, let's see how we are going to satisfy that condition of the problem. Tell me one thing. You have 2 here, right? You have 2. You have 6. Okay, you have 1. Fine, 1 and 2 can be consecutive. Okay, just keep this track in your mind. What is a subsequence before we move ahead? Subsequence means that you are selecting an array, a smaller array or maybe an equal array, in which the elements need not to be contiguous. Okay, they need not to be continuous. There should be elements that belong to this array in this order only, but they need not to be contiguous. Okay, fine. So let's have a look. 2, 6, 1, we have 9, we have 4, 5 and 3. Can you pick those elements which, let's say, if I put them in one box, they can form a consecutive sequence? Let's see. If I put 1, okay, if I put 2 from this array only, I can put 3, I have 4 also, I have 5 also. So this is one set of elements which are consecutive, right? So if you were to return this as answer, if you were to return this as an array, okay, or an array list, how would you return it? You would return it in the same order as it is in your given array. So if you were to return, so you will pick the elements from this array which are 1, okay, 1, but 1, let's place it here. There is 2, 2 comes before 1. Then there is 3, 3 comes after 1. Let's see where to place it. Then we have 4, 4 is before 3, so it should be before 3 only, and 5 is also before 3 but after 4. So ideally, if you were to return this subsequence, it should look like this. Okay, now what is the length of this subsequence? The length of this subsequence is 5. Okay, am I missing something? 1, 2, 3, 4, 5. There is 6 also, so I can return 6 as well in this subsequence. Now what does it look like? It looks like 2, 6. Let me write it properly. So basically the answer for this given array would look something like this. Not that we are going to return the exact array or the array list, we want to return the length of longest subsequence in which all the elements are consecutive. So if you were to return an array list, it would look something like this: 2, 6, 1, 4, 5 and 3. You get this? Now tell me, doesn't this subsequence, let's check conditions one by one. First thing, is it a subsequence? Is it a subsequence? Let's check. Yes, all the elements are being picked up from the given array and they are in the same order as it was given in our given array, right? So the order is also same. So subsequence is there. Now we have to check the elements present in this subsequence. elements in subsequence should be consecutive. Now what do we mean by this? That all the elements that are part of your subsequence, they should be consecutive elements. That is, if I am starting from 2 and let's say the last number of this, let's say, is 9. So all the elements from 2 to 9 should be present in this subsequence. That is what I mean when I say they should be consecutive. So what is the smallest element of this subsequence? 1. Largest is 6. So am I getting all the elements from 1 to 6 in this subsequence? Yes. 1, I have 1, I have 2, then I have 3, I have 4, I have 5, I have 6. So basically, now second condition is also satisfied. The third condition is the length of this subsequence, whatever the subsequence is, length should be maximum among all such subsequence. So for that, you can check yourself that we can get more such subsequence in which we can have consecutive elements, but the maximum length subsequence would be this. So what we need to return is this length. Okay, the maximum length of subsequence with elements which are in consecutive order, right? Okay, and the consecutive order need not to be matched. Okay, means you need not return the elements in the consecutive order. The order should match with what is present in your array. That is how a subsequence is made. So now let's check if it is the largest length. Yeah, you will get other subsequence also. Let's say this is also a subsequence. Let's check what other subsequence we could have gotten. We can get 4 and 5 from here. This is one subsequence with it also has elements in the consecutive order, and it is also a subsequence. Can I have 4, 5, 3 as one subsequence? This as subsequence? Yes, I can have. Can I not have 1, 2, this 2, this 1, then this 4, this 5, this 3? Yes, I can have. Can I not have 2, 1, 4, 3? Yes, I can have. This is 1, 2, 3, 4. I can have as many I want, as many I can get from this, but the length, maximum length I will find will be of this subsequence. Okay, now let's come at the problem solving. How can we solve this problem? So the very brute force approach that might come to anyone's mind would be the simplest one. Sort this array. So if I sort this array, it will look like this: 1, 2, 3, 4, 5, 6, 9. Now in this sorted order, just iterate over your array and keep iterating and check that you are getting the elements in sorted order. Obviously you're going to get the elements which are greater than the previous one. You just need to check the difference is not more than 1. Difference should be 1 only. As and when you proceed, the difference should be 1. So if I'm here, the next element is 1 plus 1, the next element is 2 plus 1, next element is 3 plus 1, next element 4 plus 1, 5 plus 1, next element is not 6 plus 1. So you need to stop here, and whichever index you are at and whichever index you started from, you just calculate what is the length of it. So that's, you don't even need to calculate from where you started, because you reached here only because you started from this index. Okay, so let's assume this was your test case. Means after sorting you might have got something like this: 1, 3, 4, 5, 6, 8, 9. Okay, let's say this was your array. How would you find now? So what would you do? You will start your iteration from here. You will simultaneously keep a track of length. Okay, and in the end, whatever will be the maximum length should be returned by this length. So right now you are at 1. Then you come at this position. So you check, is it 1 plus 1, 2? No, it is not. So basically, what is the length of this subsequence? So the length of subsequence so far is this index, and whatever index you started from, you are currently at this index. Okay, minus this, so you get length of 1. So this is what you are going to get so far. Now you start from here, you come here, 4. Okay, it is plus 1, 4 plus 1, this is also fine. 5 plus 1, this is 6, this is fine. Then you come here at this position, you come at this position. Okay, then this is 8. Okay, it is not 7, so that means that you need to stop here. This is the end of that subsequence which we were iterating over. So now you just keep on updating your length. When I started from here, my new length, let's say, came at 1. Or you can also keep a track of IDX index also, that whichever index you are starting from. Okay, so IDX was 1 that time. Now which index you stopped at? 2, 3, 4, 5. At 5 you stopped. So what you want to do, 5 minus 1 is 4. 1, 2, 3, 4, that is the length. So you update this length by 4, because you compare which is the maximum length of the so far. So maximum length so far is 4. Okay, and now your current index will be 5, because now you're starting from 5. This is where your subsequence broke, right? This is where a subsequence broke. Now you start from here, you go to the next index, it is 8 plus 1, fine, you are here. Then you come out of bounds. Now what was your IDX you updated to 5, and now currently you are at nth index, which is 7. So 7 minus 5 is 2. Is current length greater than your? Yes, it is. So you do not need to update length, and finally you return 4 as your answer. Okay, so this is one way in which you are sorting it, and sorting typically takes n log n of time complexity if you use arrays.sort, right? And then after sorting, you are running one loop over this and keeping the track and returning the length. So this is typically n log n of time complexity. Now we want to optimize this approach. How can we do it? That is where, can you think of something? Can you think of something here? Let's have a look. So let me write one test case here so that you can understand it. Let me take it as I think I took a test case, just a second. 2 2 6 1 9 4 and 5 4 3. So I wrote down this test case for you. Let's understand via this example. Now how can we optimize this approach? Can we do something else? So in this problem, can you think of, I am at this index, okay, I'm at this index, I'm at 2, fine. Now I come at 6. So what I basically want is, I want to know 2 is there, fine. If let's say I had 1 already present in this array, then obviously 2 can add to the length of the subsequence, which will start from 1. Okay, but for that, how do I know until I iterate over this array that I have 1 or not? Because this is obviously not going to be in sorted order. This can be in any order. But whichever element I am, I have 2 options. What I can do is, either this element, this ith element, can either append itself, can append, not exactly, see, when I say can append, this is for the explanation purpose, not that we are going to exactly append for this problem in our code. This is for your understanding, that how can it create its answer. It can create its answer in 2 ways. One way is, either this ith element can append to a subsequence which is ending by, to subsequence ending with I minus 1 element, right? Or it does not have any subsequence ending with I minus 1, so it starts the subsequence with first element as I, right? So these are the 2 options. So if I can know in some way that, do I, for any element, if I can already get my answer, that do I have I minus 1th not I minus 1, this current element, let's say this is denoted by cur. If I have cur minus 1 available with me in this array, so I can add myself and my length can be incremented, right, of that subsequence. So I need to know that. For that, what if I use a hash map? Let's assume that I am using a hash map. But what will happen is, hash map will take, if there are repetitions, how are you going to store it? Let's say there is 2, there is 6, there is 1, 9. Hash map is going to take as many elements you have, and let's say I store their indexes. Okay, so fine, you took it, no problem. But what you need to do is, does your hash map contain this? Let's say I am at 2, I ask if map dot contains 2 minus 1. Map will say yes, it contains. Okay, it will give you answer, it will solve your purpose. But in this problem, I'll be introducing you with another thing, which is also a hash map instance. It's a hash map instance which is known as hash set. I'll tell you why. First thing is, in this problem, you do not need to know what is the indexes. This problem can be solved without using this extra space of storing values of these keys. Okay, so here we introduce hash set. Hash set is nothing but it's some hash map instance. Okay, and it also implements that set interface. And then important property of hash set is that it only stores unique values. Why? Another thing is, it does not store in key value pairs like in hash map. It does not store it like this. It stores one element, right? It stores one element against it, which is unique. It can store null values also. It stores unique values, and it does not store in the way hash map does, like a key and a value pair. So what hash map does is, it will tell us, and the other methods are almost similar to a hash map. Like if you want to check if an element is present, I will just ask if it contains, if set dot contains, right? There we used to use contains key, here you will use contains. Okay, so what happens is, just assume that this is your set. Okay, this is your set. Just assume it. In your set, what will be present is, your set will, you will run a loop over this array. You will do what? Keep adding set dot add arr of I. Okay, so in this case, I have 2, I have 6, I have 1, I have 9, 4, 5. Then I have a 4 again, which need not to be stored again. Hash set will decline. It says that I already have 4, so there is no need of another 4 in my, it only stores unique values, so one more 4 won't be added. Okay, then there is 3. Another thing is, it does not maintain order. If you want to know what is, in which order I have inserted the elements, it is not going to give you that order. It just stores by some hash value, which is stores the elements with some hash value it has, which that is what, how it used to move to that element or get the address of that element. There is no order in which it stores. Like in arrays, we have the order in which we are storing 0th index, 1 index. Here we do not have that order. Okay, what it has is only the keys or that hash values. Fine. Okay, coming back to your hash set. 1 second. Now, how will this hash set help me? Let's go back to your problem. So in this problem, when I am at 2, I ask if my set does not contain, if either it contains 1, which it does. If it contains 1, then okay, don't do anything as of now. You have to check if my set does not contain, set dot contains, and this is not okay. If it does not contains what? ARR of I minus 1, which means if it does not contain, I am at currently 2, my iteration currently is for 2, so it will ask, does it contain 1 in your hash set? Yes, it does. Don't do anything, go to the, it does, right? So you, what is stored in your hash set? 2. Now 1 is already there, so you move to the next element, 6. Your condition will ask, does set contains, what is 6 minus 1? 5. Does it contain 5? Yes, it does. Don't do anything, move to the next pointer. Now you are at 1, so you will ask from set, do you have 1 minus 1? That is 0. So it will say no, I do not have, which typically means that 1 can itself form a subsequence whose starting will be with 1 only. You getting my point? So 1 would be the smallest element of that subsequence, and now my target would be till how long can this subsequence go such that all the elements are consecutive to 1. Okay, so what happened was, whenever I was getting an element which was 1 less than the current element, that means a subsequence might exist whose ending element can be that current element, right? For example, when I was searching for 2, I got 1, which means that okay, there can be a subsequence which have 1 and 2. So I want to ultimately find the smallest element of that subsequence. For that I am iterating until I get an element whose -1 is not present in your set, so that I am ensured of this fact that I can form a subsequence whose starting element will be this element. Now I will find till what length it can go and calculate its length. That is how I am going to iterate over this array. Okay, so when 0 was not present in your set, what I am doing is I am iterating over the remaining elements in your array till what? Okay, not even remaining elements. You will store some, let's say your current element is what? ARR of I. Now you check, while I'll tell you what is the condition. You check if ARR of I plus 1 is present in your set. Now let's see, 2 was present. Okay, so you will make your current as current plus 1, right? You can do so while your set contains this. So this condition will go till what? Till the time while set dot contains what? This current element. And if it contains, let's say when I was at 1, I check set did not contain 0, so I store my current as 1. Now while your set contains this current element, so 1 is present, you go and check for current plus 1, so cur becomes cur plus 1. Okay, fine. Again you check for, now current will become 2. Is 2 present in your set? Yes, it does. Now current becomes 3. You check for set contains 3. Yes, it does contain 3. Now you go to 4. Does set contain 4? Yes, it does. Now you go to next element 5. Does set contain 5? Yes. Now you go to next element. Does it contain 6? Yes, it does. Okay, so now you go to next element 7. Does your set contain 7? Now that is when this condition will fail. So current will say, so this condition will say set does not contain 7, so come out of this loop. When you come out of the loop, you want to store some length. What is the length you have found so far? So your length becomes, what is the current value? Current is 7. What did you start with? You started with ARR of I. So ARR of I plus what? 1. And 7 minus 1 is 6. So basically you have gotten elements from 1 to 6. 1, 2, 3, 4, 5, 6. How many elements these would be? These are total 6 elements. How can you get this length? Current minus ARR of I. Then you calculate what is the maximum and store it in length. Length equals to, or answer, let's say answer equals to max of your current answer, whatever must be, and the length you recently calculate. And after all of these for loop, and here you are running a for loop in which you are doing, you return this answer. Okay, this is just a pseudo code for your understanding. So did you understand what we did here? So we made use of a set which will contain the elements present in your array, all the unique elements present in your array. And once you are done, you are iterating over this array. What you are trying to do, you are trying to find that subsequence which will start the starting element of that subsequence, and you will go and check that till what it can go. Okay, so this was when you came at 1. Okay, go to the next element. Loop will not stop, right? Loop will not stop. You are at 9. So does your set contain 8? No, it does not. Go to the next element. 4. Does your set for 9 also a new subsequence can be found. Whenever the set does not contain that element, that means that element can give a start to a new subsequence. Now my target is to find till what this subsequence can go. So for that I am doing all of these things. Now I go and check if my set contains 9. Yes, it does. I go to the next element 10. Does it contain 10? No, it does not. So now when I come out of this while loop, it will check what is the length I can find the subsequence which starts with 9. So the subsequence that will start with 9 will give me a length of only 1, because I did not find 10 in my set. So length will be updated with 1 and answer will be updated with max of answer and length. So answer is what? 6 as of now. So it will remain 6 only. Then you go to the next element 4. Does your map contain 3? Yes, it does. So you do not go into this condition. You come out. You go to the next iteration. Does your map contain 5 minus 1? 4. Yes. Don't do anything. Come at this position. Now if you also, one more thing, I already found 4 previously. Now I am going to do this, repeat the same steps for 4 that I tried for this 4, right? Do I want to do that? First of all, you already have 4 minus 1 3. You already checked for this 4. I think I can omit this operation for another 4. That means you can omit your operations, you can avoid the repetition of operations if there are duplicate elements. So I'll just write a line whenever I'm done with one element, just remove from hash set. You remove from hash set, that's all. If I'm done with 2, I will remove it. We can do that thing, not now, but even if you don't do, your question will work, but just for reference. Okay, then you come at 3. Is 3 minus 1 2 present? Yes, 2 is present in your hash set. You don't do anything and you come out of the loop. Okay, so that is about this problem. Let's go and solve this. By that time, let me check if you guys have any doubts. Even I got to solve this, but how to build intuition for O and I'm curious. Yeah, so importantly, this problem can be solved in other ways also. Mostly the optimized ones are going to use some extra space. There's one other way in which you can maintain a DP array. Okay, there is one other way in which you can use a priority queue, and this hash set we already discussed. The reason I'm discussing this hash set is so that you can get introduced with this hash set also under this hash map of topic of your SD sheet. But I would suggest you can, this is the intuition you can get, I'm sure, but you can also get other intuitions, and you can try a DP method for storing the answers, and you can make for creating the answer for the other elements. Okay, and there is this other one, priority queue. If you do not get priority queue solution by your own, you don't have to worry about it, because once we come to queue, maybe I can take this thing that time. And if you are well aware of what priority queues are, then I would suggest you can try it on your own. Fine, so let's go to the code now. Let's create a hash set. I told you it's nothing, it's teacher, just a second, new hash set. So it's a hash map instance only. It's just that it only stores unique values, does not store in the form of key value pairs, and it can store null values also. It does not maintain the order in which you have stored the elements. Okay, fine. For you just store the elements in your set x belonging to ARR set dot, you use dot add method only. Okay, here also. Now for int I0 I is less than n I plus plus, let me change this to small n. What you are doing, we were checking if your set does not contain that element, right? Set dot contains, here you don't use contains key, you use only contains as your method to check if the element is present or not. ARR of I minus 1. So if your set does not contain this thing, what you want to do, you going to first, let's store this answer as int current equal to ARR of I. So before that, if this is the case, so while int cur equal to ARR of I, while set dot contains this current value, what you are doing, while it is containing this value, then you are moving ahead by cur plus 1. You can do it cur plus equal to 1 also. Okay, but for explicitly I'm writing it, you are doing current equal to current plus 1. Okay, if your set contains, when you come out of this loop, that means now the last element for that subsequence you have found, now you want to find the length. So int length is equal to whatever the current value will be minus ARR of I as you started with, and let's store our answer in int answer equals to 0, and update our answer with max value of answer and length. What is the max of 2? ns comma length, right? Length. And finally, when you are out of this for loop, you return this answer. Let's check if we are able to solve this problem or not. Fine. So that is all about this problem. If you have any doubts, you can ask me. Otherwise, we are done for this. Also, the important thing is, as I saw in this doubt section, this ON time complexity, this particular solution is ON of time complexity only. Let me explain you how. It's just that we are using some extra space, but other solutions also which I discussed will use some extra space. Now let's discuss how it is taking ON of time complexity. So we are running over the loop once here. This is big O of n, right? Then this is again big O of n. But both the time complexities are, first you are doing this step, then you are doing this step. So this is big O of 2n total so far. Now this condition asks you, if your set contains that does not contain that ARR of I minus 1, then you are finding in set if that current value is present or not, and you are updating your current. So searching in a set here can be assumed to be O of one time complexity. Set returns you if the element is present or not in O1 of time complexity. So this is O1 of time complexity, and that's how this entire solution turns out to be big O of n time complexity, and space of On, which is the space utilized by your set that you have created. So I hope this problem is clear to you. If you have any doubts, you can ask me. So this is all about this problem for today. If you have no doubts, we can wrap it up. The minimum height 1 and 2, minimum height 1 and 2. Can you send this in chat, the problem link? And for your understanding, let me also tell you that we are following this SDE sheet, and we have already covered arrays. Then searching and sorting is also covered. You can find it in my playlist of SDE sheet in under Geeks for Geeks practice channel. Then we are done with hashing also. Just one more question to go. In my tomorrow's lecture, I'll be discussing this problem, and then we'll start with matrix. That's how we are going to proceed in this our SDE sheet. So if your question belongs to something which you have already discussed, you can go back to my video and check. Otherwise, we are going to take them in this order. Okay. So that is all about today. I hope you understood it. Let's wrap it up then, everyone. Okay guys, see you tomorrow. Thank you everyone. Bye bye. Take care.